Looking at number 17, it says due to turnover and absenteeism in an assembly plant, 20% of the items are assembled by an inexperienced employee. Management's determined that customers return 12% of the items assembled by inexperienced employees, but only 3% of those assembled by experienced employees. So let's make a tree diagram on this one. The employee has experience or he doesn't have experience. From the first line, I know that 20% of the employees don't have experience. That means that 80% do. Now, the employees that are experienced assemble products. Some are returned, some are not returned. Likewise, the inexperienced employees have some returned, some not returned. It says 12% of the items assembled by inexperienced employees, that's on the bottom, are returned. That's this number. 12% are returned, which means 88% are not. Of the experienced employees, only 3% of these are returned, which means 97% are not. Then I would multiply down each branch of the tree to get these four numbers. Those two numbers add up to 80%, and these two numbers add up to 20%, so the sum of all these red numbers is 1, or 100%. Now the question is, what's the probability if I tell you it was returned that an inexperienced person made it? Well, where are the items that are returned? They're here and here. Those are the items that are returned. That's what ends up on the bottom down here. So that's 0.024 plus 0.024. 0.048. Of those, which ones are made by inexperienced people? Those. So that's the number that goes up here on the top. 0.024 divided by 0.048 is 0.50.